Welcome back, focused learners. Let's just dive right into today's explainer. We are demystifying the absolute fundamental mechanics behind literally every single piece of technology you use. We're going to look at how computers actually process information to solve our problems. It all boils down to three simple things: input, process, and output.
So, how do computers use input and output to get and give the information they need to solve problems? It's kind of a fascinating thought, right? Take a second and just imagine how a machine actually thinks. It doesn't have a squishy human brain like ours, yet it solves these incredibly complex problems every single second of the day.
To answer that, here is our roadmap for today. We'll be covering 1. How computers solve problems. 2. What are input and output. 3. The input-process-output cycle. 4. Designing problem-solving apps. 5. Expanding inputs beyond users. And 6. Everyday computing examples. Let's get right to it.
Section 1. How computers solve problems, the human connection. Before we get bogged down in microchips and code, let's root this whole machine logic thing in a super relatable human scenario. Imagine you're trying to recommend a pet to a friend. You wouldn't just guess randomly, right? That'd be a disaster. You have to ask specific questions to gather data first. You'd ask, are they allergic? Do they want an active or a quiet pet? Do they even have yard space? How much free time do they actually have to care for it? If they tell you they live in a tiny apartment, they're super allergic to cats, and they want a quiet pet, well, you might confidently recommend a fish. And this little scenario brilliantly illustrates our core concept. To solve the problem of picking a pet, you went through 3 distinct steps. Step 1, you received information. Step 2, you thought about it and made a decision based on those constraints. And step 3, you gave your recommendation. Well, guess what? A computer relies on this exact same 3-step process.
Section 2. What are input and output? The core concepts. Let's pivot from human behavior to defining the formal vocabulary that actually powers all of our machines.
First up is input. By definition, input is the information a computer gets from users, devices, or other computers. Think about it. Every single time you type a name, click a mouse, tap a touchscreen, or even speak into your microphone, you are actively feeding that machine the data it desperately needs to start solving a problem.
On the flip side, we have output. This is the information a computer gives back to users, devices, or other computers. Basically, it's the result. It could be the actual words lighting up on your screen right now, music playing through your speakers, map directions to a local coffee shop, or honestly, even a simple physical vibration from your phone.
So, the crucial point here is incredibly simple to remember. Input goes into the computer, and output comes out of the computer. That is the golden rule. Definitely keep that in mind as we move forward. Section 3. The input, process, output cycle. The 3-step cycle. This is the absolute heartbeat of all computing.
Every single computing task follows this exact sequence: input, process, output. Think about a standard calculator. You enter a 7, a plus sign, and a 5. That's your input. The computer then instantly processes that information by following its deeply programmed math instructions. Finally, it displays the number 12. That is your output. Systematic, precise, and remarkably fast. Section 4. Designing problem-solving apps. App design in action. Let's actually see how this builds when we go to create real-world software.
Imagine an app called Story Creator. You type in some specific words. Let's say a name like Sophia, a place like the moon, an animal like a rabbit, a color like purple, and an action like dancing. These typed words act as your direct inputs. The app processes them, seamlessly sliding them into a narrative template. And the output? A personalized story displayed on your screen about Sophia dancing with a purple rabbit on the moon. And hey, if the app reads it aloud to you, that spoken sound is just another output.
Now, what's really interesting here is that identifying these inputs and outputs is quite literally the very first step to designing any problem-solving software. Look at the homework helper idea. To give you a useful schedule output, it absolutely must first receive your class name and due date as inputs. Or take a lunch chooser app. It can't suggest a meal or give you directions until it takes in your food preferences and your budget. The entire process relies entirely on getting the right data first.
But we do need to clarify a pretty crucial nuance here. There is a strict difference between the device itself and the information. A keyboard is just the physical input device. The typed letters themselves, that's the actual input information. A microphone is the device, your voice is the input. The screen is the output device, but the images and text displayed are the output information. Make sense?
Section 5. Expanding inputs beyond users. Modern computers are way beyond just waiting around for us to type on keyboards to gather their data.
Our devices are packed with these incredible, often totally invisible sensors that are constantly feeding them information. Your camera provides images for face recognition. The GPS provides location data so your maps can actually work. A motion sensor detects movement to count your daily steps. And of course, the internet itself is a massive source of input, pulling in live data from other computers like current weather or real-time traffic conditions.
So let's combine all of this. Think back to our pet recommendation scenario from the very beginning. An improved pet app wouldn't just ask about your allergies in space. It would use your phone's GPS sensor to find your exact location, then pull internet input to check nearby pet store hours and current traffic conditions. The output becomes vastly more powerful. It doesn't just recommend a fish, it gives you the store name, the best driving route, and your estimated travel time. Combining these inputs absolutely changes everything.
Section 6. Everyday computing examples. Let's do a quick check for understanding to see how well you've grasped all of this.
Imagine you press play and a song begins. Pretty simple, right? But what is the input here? I'll give you a second to mentally lock in your answer. Got it? Okay. Let's see if you were right. The input is the physical act of pressing the play button. The output is the music playing from the speakers. And remember, a single device can even have multiple outputs simultaneously. If you get a text message while that song is playing, your phone might vibrate, play a chime sound, and light up the screen all at the exact same time.
Okay, here is a final exit check for you to ponder. Think of your own favorite everyday app. Maybe the one you use the absolute most. Ask yourself, what specific problem does it solve? What is the input? Where is that input coming from? Is it you, a sensor, the internet? And what is the final output?
Let's take a navigation app, for instance. The problem? Finding the absolute best route. The inputs are your destination, your GPS location, map data, and live traffic. The sources are the user, the device sensors, and the internet. And the output? The drawn route on the screen, the map display, your estimated arrival time, and those spoken turn-by-turn directions. It perfectly demonstrates how a highly complex daily tool completely relies on that brilliantly simple input-process-output cycle.
We are going to conclude right here with our foundational rule. Input goes into the computer and output comes out of the computer. It sounds so incredibly simple, but it really is the key to understanding all technology. So, as we wrap up this explainer, I'll leave you with this little question to chew on. Take a look at the very device you are using right now. What invisible inputs is it silently gathering to power your experience with this explainer at this very second? It's definitely something to think about. Until next time, stay curious and keep learning.